You guys are doing well. So continuing on our journey, today we will be trying to understand what TypeScript is, and we'll see some examples and we'll try to complete little bit of TypeScript. Okay, so basically TypeScript, right? Now JavaScript has uh, this issue, right? So there is no type safety in JavaScript, right? So first is basically why do we need, or what is the need for using um, TypeScript, right? Now because we are sick of those weird cannot read property, right? And of the undefined JavaScript errors, right? Or maybe we are TypeScript can help your code scale better, can help us to scale our code better, and we wanted to see what all the fuss is about. So basically we are a C hash person and we have been thinking of trying out this whole JavaScript thing, or we are a functional programmer and decided to take next level. Now TypeScript is the language that will power the next generation of apps, right? And Node.js projects, Internet of Things, and other things. It will make your program safer by checking for common mistakes, serve as documentation for yourself and future engineers, making refactoring painless, and make like half of your unit tests necessary. So what are unit tests? The TypeScript basically is going to double our productivity, right? Now, before we go across the street, let's unpack why do we need, like, what do you mean by type safety? Now, using types to prevent the program from doing invalid things, right? For example, when we are the whole, so basically TypeScript, right? Yeah. Our goal is basically to make sure that we are doing something called as we are doing type safe operations, right? Now, when we say type safe operations, first is basically like what are not type and say, for example, multiplying a list by a number, right? So this shouldn't happen, right? Calling a function with a strings of strings when it actually needs a list of objects. So for example, calling the wrong function. Calling a method on an object when that method does not exist. So calling a method on an object when in reality the method does not exist, right? So all these are basically nothing but issues, right? Now uh, there are some programming languages that try to make the most of these mistakes. They try to figure out what we really mean when we did something invalid, right? So because hey, you do what you can, right? So for example, JavaScript. Now Javas notice that instead of throwing exceptions when we try to do things that are obviously invalid, JavaScript. So this is the beauty of JavaScript, right? JavaScript never returns us or never throws an error, right? So if it does not find anything, it gives us that undefined error, right? So basically, that is going to break our code, right? So Java tries to make the best of it and avoids exceptions whenever it can. So is JavaScript being helpful? Certainly, because this makes making, for example, when you're doing a divide by zero, right? Or whenever, for example, you have a function here, and inside you're passing a number, and then you're doing a mathematical operation, and while calling, you're giving an alphabet, right? So this shouldn't happen, right? Instead, what you will get is undefined. You won't get an exception. Imagine if JavaScript accepts through exceptions instead of quietly making the best. We might get feedback like something like, so we might get exception occurred, error, or something like that. Don't get me wrong. Trying to fix our mistakes for us is a neat feature of. So basically, JavaScript will try to fix the mistake, right? So it makes life easier for the programmer, right? So its goal is to make life easier, right? But if you consider big environments when you're having a huge production, then this kind of becomes an issue, right? But for JavaScript, this feature creates a disconnect between when you make a mistake in your code and when you find out that you made a mistake in your code. Often that means that first time you hear about your mistake will be from someone else. So here's the question: what exactly does JavaScript tell you? But when we make a mistake, right? So when we run your program, our program might run But when you test in a browser, or when we do a unit test or something, or unit visit, then it might not function as we intended to, right? But JavaScript did not tell us that it might not, that there is no um, like JavaScript did not indicate to us, right, that there was an error. So this is the whole point, right? So here's where TypeScript comes in. Now, even cooler than the fact that TypeScript gives you helpful error messages when it gives them to you. Now TypeScript gives you error message in your text editor as you type. This means that we don't have to rely on unit test or smoke test or coworkers to catch these sorts of issues. Now TypeScript is going to catch, for example, if I'm trying to add a number and a list, right? So TypeScript will here itself, it will give us the error saying that, error, and that error will be not something which will be an alien language. It will be like operator plus cannot be used, or method does not exist. In addition to eliminating entire class of type related blocks, this will actually change the way we write code, right? You'll find yourself sketching out a program at the type level before we fill in the value. You think about edge cases as you design the program, not as afterthought, and you will design programs that are simpler, faster, and easier to understand. So depending on which statistically, so basically, yeah, this is what we need to do, right? Not TypeScript. Now, in this, so basically, our issue is with TypeScript. Our issue is with the main thing is we want some type checking to happen, right? JavaScript does not, JS does not, or the JS does not perform this. So we need some sort of some mechanism to achieve this, right? It gives us undefined instead of telling that there was an error. So we may think that we might have written a proper code, but when we really try to test it, we might get an issue, right? So that is going to happen at the production level. So instead, so TypeScript saves us this time and makes us to think type way even before we are writing the code on the production. Depending on, so now TypeScript. So now how does TypeScript work, right? Our goal is to understand this. Depending on what programming languages we have worked before we decided, you will have a different understanding of compile of program works, right? The way TypeScript works is unusual compared to our other is like JavaScript or Java. So it's important that we are in the same boat. So let's start the program file. Programs are files basically. So let's go deep root, like, so this is the program file, right? So when we write this is generally will be this is present in my hard drive, right, in a file in our folder, whatever we are doing. So now that text is passed by a special program called as compiler that transforms it into an. So now this thing is, when we try running it, it is then passed through a something called as a compiler, right? So what does this compiler do? This compiler will generate an abstract syntax tree for us, a data structure that ignores things like white spaces, comments, where you stand on the tabs, spaces, and something else. The compiler then converts that AST to a lower level. So then, when we are actually running it, we are going to convert this AST to something called as the bytecode, right? It's eventually this bytecode. You can feed that bytecode into a program called a runtime, right? So then this bytecode is given to my CPU, right? Or then I have placed it in my OS for scheduling. So this is the bytecode that is. So it is not exactly a bytecode. It is a C-like code. So, well, to sum it up, what we can say is, what happened is, first is, this is the code from the HDD, or the code in our memory, right? So this code uh, gets converted into something called as an abstract syntax. So this is the code. Then I have an abstract syntax tree. After this tree generation, uh, so what I'm going to do is, so once I have this tree generated, then I'm going to parse it and convert this into this is going to be my bytecode, right? And it is this bytecode that is then being fetched to the compiler, right? So then it is this bytecode that is going to the OS scheduler, right? Now where TypeScript is typically is that instead of compiling straight to bytecode, TypeScript compiles to JavaScript code, then you run that JavaScript code. So now where TS will present is, the TS will convert it into JS code, and then we will give it this thing to the scheduler to run, right? So this is how it's going to work. Now uh, because browser can only understand two things, right? So browser can only understand three things. First is basically HTML, then it has to be then it can be then it is CSS, and the third thing that the browser will understand is JS. So if you're writing JS, we need to convert it into JS before we can use it, right? Now, so that is why, so what we do is, so we write our program in TypeScript. So this is our TypeScript source. Then we convert this to say TypeScript, an abstract syntax tree. Then this tree is going to be type checked, right? So we need to perform that type checking, right? Remember, our main goal of doing is performing the type checking. Then once this is done, then we again have it converted to the abstract tree, and then to finally, as I said, we need it to be converted to JS, right? So ultimately we need by some mechanism to be see, somehow we need this thing to be converted to JS, right? So you use this that is going to be run in our browser. So this is how our TypeScript. Now the JavaScript comparison runtimes tend to be smushed into a single program called as an engine. So we know engine, right? For example, Google has the V8 engine, Node.js again has the V8 engine, then we have Spider Monkey, Firefox, then we have Chakra. Okay, then so the type process, right? Now the modern languages have sorts of different uh what do you say type system. Now there are generally two kinds of type system. Now type system in which you have to tell the compiler what type everything is. So again, type systems can be of two things, right? So this is pretty straight, right? Either, so one is where we implicitly do, and the other thing is, so the other way is basically explicitly, right? So this is the two possible ways. Now TypeScript is inspired both. So TypeScript have both. So if you don't mention, then it will kind of make an assumption, right? To explicitly signal TypeScript what our types are, we need to use something called as annotations, right? So for example, so basically this is more like in Swift, right? It does both. So this is what we mean by when we say annotations, right? We need to specify, or we need to specifically mention the type. So this is what if you want TypeScript to infer your types for you, just leave them off and let TypeScript go to work. Right away you will notice how good TypeScript is inferring types. If you leave it up, the types are the same. Throughout this book we will use annotations whenever there is necessary, right? TypeScript works its inference magic for us possible. Now TypeScript is JavaScript. Now let's take a deeper look at TypeScript. How are types bound? So it's in JavaScript it's dynamic, right? But here we do statistic, right? But we do at compile time itself we kind of declare. Now dynamic types, basically JavaScript makes an inference at the runtime, right? But then because it is making at the reference at the runtime. So this is the thing, right? JavaScript does not care whether we are. It will run everything, but it will not give an. It will never give an error. It may say something as an undefined. So that is because we are already at the runtime, right? So we don't want things that to happen. So if you do something that doesn't seem right, TypeScript will immediately give you at the compile time itself. You are doing something wrong. You need to change. This behavior makes sense. Who in their minds will try to add a number in an array and expecting the result to be, because when at compile time we know what how certain operations have to be performed, right? It makes it hard for individual engineers to get their jobs done and makes it even harder to scale code across a large team, since every engineer needs to understand the implicit assumption that code makes. So basically, if you do explicit, so we do it explicitly, right? So implicit is, this is not the preferred way, right? So this is, again, we don't want this thing to happen. We want explicit mention of the types. This is our goal, right, to achieve. Okay, so now when our types checked, again we said types are going to be checked at the compile time instead of at the runtime, right? The code address. Now we have some information about. Let's try to code little bit. Let's try to have some setup done. So let's the thing is, will it open? I don't want to spend time sending the path again. Let me try. If the path is sent, then it's good now. Yeah, this kind of. So right now we are just going to open Visual Studio. So we are going to go have a terminal here. So let's do ls. So right now we are in. So we are just on the main thing. What we can do is, we are, I guess, in the, no, this is not even in the desktop. So let's make a new directory saying chapter -2. Let's move to, oh, now let's, so now we will be having some directory here. I have 10 oops in, yeah, I have that. So now let's move to that. So let's go there. So now let's do here, let's initialize in npm, right? So the moment we do npm, use, okay, npm, yeah. So let's keep on doing enter common.js. So now we have everything. Now once we do this, now we are going to do npm install, and then we are going to do, this is basically to save, and then we are going to install TypeScript lint, and this is called as linter, right? So again, this is something that is important, right? And then yeah, so now it's running. Error now. Okay, it's not saying, it's giving an error, right? I guess it should be npm install TypeScript, maybe. Yeah, just do npm install -g. Okay, do npm hyphen. So -g is for global installation of TypeScript. So yeah, so now let's do ts-v. Should give us the version, not tsc-v. So I have 5.8.2, right? So okay, I've got TypeScript up and running. Now okay, so every TypeScript project should have a file. So I am, because, okay, if I do open, yeah, if I go here now, it will be, yeah, the node models and everything. So I have the package.log JSON. I have TypeScript as well. Okay, I have the config files and everything as well. Now these are just few available options. TS, so now we get certain files, right? So for example, if you go, there is TSC server, TSC, you have so many of them, right? You have some, so one of the important file is going to be TSC lint. A project should have a TS lint, a JSON file containing a TS lint codifying so there should be something called as index, or we need to create our TypeScript file, right? So let's do and create uh, index.ts. So this is index.tsc TypeScript. So we have the TypeScript file right now generated. Now projects folder structure should now look node module just as, so he's telling inside source. I have, so yeah, I can create one here as well, and then this things inside source. So uh I have node modules, I have TypeScript, okay. Then outside I have package.json. Now pop open. So let's do let's try running. So I'm going to do console dot log and let's do something. Say hi. Let's say hi. This is extra. So now let's go back to our terminal. So we are already in chapter 2, right? Let's try. So first is compilation, right? Because remember we need to do compiling a TS file, and then and automatically when you compile it, a JS file should create. So let's call the compiler. So this is tsc index dot. The moment you run this, the file index.ts is not found. Oh, I need to go to okay, so let's do ls, let's do go to, so yeah, we are in the outside directory, right? Let's go to node, let's go to node modules. Ideally we don't put here because we are going to keep ignore node modules, right? Okay, so but that's just okay. So let's go to src. Now let's do tsc index.ts. So now, yeah, the moment you have the same JavaScript file is going to be created. Okay, we got the JavaScript file. Now that your environment is set up, so we can write some code, right? So let's go back to here and let's say that is equal to 1 plus 2, and then let's do let b is equal to 1 2 plus a, and then let's say let's have an object. So we create an object here and then say let's go to let's have a, let's say this is 1a, and then this is banana, right? And then let's do 2, or this shouldn't be here. Now when I do c dot happen, so let's reassign it to some value, say. Now again the same command. So now, yeah, so the moment you make this, right, so index.js also will get updated. There is some whites coming in at problems. I cannot redeclare. Where am I redeclaring? So I'm getting some error over here. Cannot redeclare block scope variable A. Where am I redeclaring it? I'm using it, right? TypeScript. So basically, if you hover over it, so yeah, A is number, right? Cannot declare. So it kind of there's some, there is something that is happening. I mean, I'm not redeclaring anything. But yeah, but I have, okay, let's say this is a B1 something else. Now A is again redeclared, it says. Let's not, let's say something like one. There might be something, because it's having both here. Oh, I guess what's happening. Is it checking for the same? If I go to index.js, I will see that later on what's the issue is. What the issue is. Okay, so install ts.node, compile it to a TypeScript file. Okay, I have done that. Now play around with your code. See if you got. Now there are languages. Okay. Now about types, right? Now type a set of. Now this is basically where we really start learning about types, right? So type. So remember, we don't want TypeScript to infer types. It's much better if we implicitly mention the type, right? So this is the whole problem. Now we are going to come with type. Now the boolean set type is a set of all booleans. They are just, so basically here you can have uh, so this is boolean. So either you can have yeah. So basically this is boolean, right? So either you can have true or either you can have false, right? Now the number type is a set of all numbers. So then we have one more type saying numbers. For example, all numbers, it can be anything like all number or arithmetic operations, and even logical operators can come. Now strings type is a set of all strings and includes the operation that we can perform on them as well. So the third basically major type here is strings. This is going to include all of the operations on the strings. Okay. Now talking about times when programmers talk about types, they share a precise common vocabulary to describe what they mean, right? We are going to use this vocabulary throughout this book. See, if I have a function that takes some value and returns that value multiplied by itself. So for example, so clearly this function will only work for numbers if you pass, because you are going to mention the type, right? So the types are being going to be mentioned by using and then annotation. Okay. Now the ABC is out. Now let's take the tour of types. TypeScript supports what values they contain, what we can do, what we can do with them, right? Now any is the godfather of types. Any, it does anything for a price. So this is godfather, right? But you don't want to ask any for a favor unless we are completely out of options, right? TypeScript is everything needs to have a type. Any is default type. So if we when you the programmer and the TypeScript can't figure out, so this is, we never want to go here. This is when we can't figure out, but this will never happen. This is the godfather, right? We don't want to ever come across, because then the whole logic of using TypeScript goes off. The rare occasion that we need to use it, you do it like, for example, any, because the moment I give it an annotation, right? Say I say is a string. I can't assign a number here, so that is the biggest problem that comes here, right? Okay, so but why are you trying to add a number and array but doesn't? Because you told TypeScript that you're adding two any's. If you want to be explicit about it when TypeScript infers, okay, now any is the godfather, then an unknown is uh, Kinuri as undercover FBI agent journey hota in Point Break. Okay, then we have something called as unknown. So any basically when we are can't figure now when to use unknown for the few cases where you have a value whose type you really don't know ahead of time. So basically this is ahead of time. So suppose if you are going to this is so here using undefined will be a better option than using any, I guess. Okay, anything that is unknown. So if it's so if it's unknown, so anything which is unknown type is going to come here. Basically we do not know the type beforehand, right? So for example, in my example I did not know what it was, right? It could be a string or a number. So at that time undefined makes sense. Now so it can be used for further refinement, right? Later on in our code we can refine the type, then any makes sense. Let's bring it. Now boolean, as we said, true or false. Now there is something called as type literal. Now in the fourth case, okay, for example, the boolean type has true values, true and false. We can compare them, negate them, not much else. We can use boolean. Now in this example shows a few into the TypeScript that something is a boolean, so we can do an annotation called boolean. Or if you don't give it, then implicitly it will try to do it, right? In the general, for you will first. So generally we'll be using the first and second way, right? We'll be mentioning the colon. Only when it buys you extra type safety, I'll show you. Okay, the second and the fourth cases. Second and fourth are particularly interesting because they do something interior supported by surprising for programming language. Hey, TypeScript, see that this is a variable each. It isn't just any old boolean. It's specific. Oh, so yeah. So there is one thing. So further, what we can do is we can also have this thing written as say let e colon 2, right? So what we are saying, so but when we say this, we say this is a boolean that is always true. So if I am assigning it, I have to give it true. So we are kind of doing the value as well, but then this is something which doesn't make sense. Which you won't be. This is very limited. In the fourth case, I explicitly annotated my variable to the type literal. Yeah, we have mentioned it true, right? TypeScript knows that once a primitive is assigned with const, it will never change. It defines the most. Okay, that's why in the second case, so whenever you try, I don't know, TypeScript infers C type as true instead of a boolean. To learn more about why TypeScript infers different types for let and const, let's go to type. We'll see that later on. We will revisit. Number again, we said it's something for all numbers, right? Then we have something called as big int is a newcomer. It lets you work with large integers. Again, you can, if you have a very big number, you can do big int. So this is something denoted by n, right? So n at the end is going to indicate that it is a big int. Okay. Uh, at the time of writing, big int is not yet natively supported by every JavaScript. So basically, yeah, you remember this is not so. Not all features are supported by JS engines, especially when we come to browsers, right? Or when we see MDN docs. Certain features are supported and certain are not. So we should be very careful about using. He's saying this is not natively this, so there is no native support for this. There is no native support, so be careful uh, while using. Make sure that we go through MDN docs and then we are whatever engine we are using, it has that. No, symbol is a relatively new language feature arrived with years. 2015 symbol not come up. Yeah, so you can use an as an alternative to string. So then you have one more type called as symbols, not oftenly used. uh okay. Objects. Now object TypeScript object specifies the shape of the objects, not notably they can tell the difference between simple objects like with more complicated the kind you create using new, right? JavaScript is generally structured types of. Okay, so then we have something called as object, right? So this is something that would be using a lot, right? So even this is an object, and even creating a using the new keyword is also. So there are two ways, right? So either I create an object using this, or I create an object using the new keyword, right? So both of them are objects, right? So even this is an object, this is a this is an object, and even this is an object, right? Both are objects, right? Now wait, that is not useful. Okay, what's the point of typing something if it's an object if you can't do anything with it? Now there are, okay, style of programming. We just get that an object has certain properties and not what its name. Also it's called duck typing, not judging by a book by its cover. So basically, a style of programming where we just care that an object has certain properties, not what its name is called duck typing. There are a few ways to describe objects in TypeScript. Right, first way is to declare value as an object. So we do object. So then narrower. So there is some issue here that is going to happen. Uh, for example, so now suppose if we do this is saying we give it an as an object, and then inside we have certain properties, right? Say we have apple, and then from outside we try to reassign apple, right? This is going to give us an error, right? So this is not very useful. So what if we TypeScript error? In fact, object is a little narrower than any, but not much. The object does not tell you about the value it describes, just that the value is an object. What if we leave out the explicit notation and let TypeScript do the thing? So there are two, right? We have just discussed the second way to type an object, right? You can either TypeScript infer using an object shape or explicitly describe it using. Yeah, let TypeScript infer it. Or what we can, okay. So instead of doing this, what we can say is, so we can say this is an object, and then you mention it here itself. So I have a property that is a number whose type is a number. So when we do this, now again we can, and this is the key and value, right? So this is going to work. Or either we do this, or either we say let TypeScript do the work. So we just write it in normal notation, right? And we say this is b is colon 10. So this is normal notation. This is normal notation, right? Now type inference when declaring objects with const. Now you might be surprised that TypeScript inferred number b as a type and not as a literal. After all, we learned that when declaring numbers or strings, our choice of constant let affects how TypeScript infers our types. Unlike primitive types, we look so far. Boolean numbers declaring an object with const won't enter TypeScript. What is this issue? What is this type? Now type inference when declaring objects with const. There is some. um thing with let and const, right, which is called as type widening. Describe the say okay, let's see this. There is something which is happening here. What is this? Type widening. He's saying this is type. The type widening is the behavior is a TypeScript behavior when narrow literal types like hello are automatically widened to more general types in certain situations. TypeScript. Okay, so let's see what is happening here. Let's let's go here. So we say type widening, right? Type. So first is we can write something like let greeting hello, right? So this is implicit. If it's written in TypeScript, this is going to make this is a string, right? Now because string is declared with let, TypeScript widens its types from oh. So here it is TypeScript influence string, right? Oh, the thing is, so there is a difference between let and const, right? The whole thing is const cannot be uh the problem is const cannot do that reassignment, right? Type binding is a TypeScript behavior that while when narrow types like hello are automatically widened to more general types like string or number. So ideally he's saying that this type has to be hello because the value is hello, right? Based on that it's going to make that implicit. But what it does is it infers this as a string instead of inferring it as hello. But if you use const then TypeScript infers this as hello itself. Now number literal winding. For example, I have age is 42 inferred as number and this is going to be literal type. Because winding affects strict typing, how TypeScript checks assignments. Uh, so the way the problem is why does yeah that's what I was going to say. In const it's not going to happen because this value will never change. We know that, right? Somehow this value can't change, but late age is 42. Yeah, it's going to infer that as literal type in const. But when we why does matter? For example, yeah, this is going to be important, right? Okay. Yeah, so we might get an error there as well. Okay, so the problem is, suppose if I have a function here, say this is greet, right? And then inside I have written it can take admin or it can take user, right? So now what is uh let role equal to okay, so if I do this and then if I do this and I pass in here, I call it greet and I try passing role. So this is going to give me an error, right? Because what it is going to do is it's going to implicitly make this as string. Yeah. So so in other words, but if the same thing if I do as instead of declaring this, I declare like const role. Now this is going to work because your type binding does not happen. So there is an issue here. So there is no type binding here. Okay. No type binding. So this is an inherent behavior, but this is only when it's implicit type, I guess. I see. Now one object little syntax is that so we were with objects, right? We were trying to understand. Okay. Now object little syntax here is the thing that has a shape. Uh, so I have a shape. Let's explore what happens when we add extra properties. So for example, we declare an object, right? So we are going to mention the yeah. So what if we forget? So for example, we have an object here and we say this has a key b which is a number, and we just make this as an empty. So this is going to be an error. Now this is the for example where we first declare a variable then initialize. No, this is okay. This is it. There's something which is happening here. Okay, where what? What is definitive assignment? Yeah, for example, we first declare a oh yeah. So what it's doing is here it's initially it's empty, right? B is then we'll get an error, but required in type. So what we see is yeah. So what we can do is in JavaScript we can declare, and it's supported by TypeScript too. When you declare a variable in one place and initialize it later, TypeScript will make sure that a variable is definitely assigned to a value by the time you use it. By default, TypeScript is pretty strict about object properties. If you say that the object should have a property called b, that's a number. Okay, with object, it is something that is going to be strict. Now, as a property b, so for example, can you tell TypeScript that something is optional or that? Oh, so here we have. Okay. Yeah, I guess I understand what I was trying to say. So here, this is going to eventually give me an error, right? So is there any way or something like an optional that is there in other languages like Swift, right? We can say that's it's an optional because again Swift is again a type safe language, right? So type has to be there either implicitly or explicitly. So what we do is now index signature. Okay, so what we the way to do is no, but then yeah, and one more thing, we cannot add in more keys, right? No, might have any okay. Also, yeah, what I can do is so I can say this is let and then I say a colon. This is mentioning the type of the key value, right? So and then this is key. So now we are bypassing that thing, right? So now this thing indicates this is an optional, right? So might have a property that's a string, and if it empties it, it might be undefined. So this is basically might have any number of numeric properties. So I can have any number. So, so what is this going to do is this is going to let us add from outside, because we are strictly type checking here, right? What if we don't know the key? So basically that is something that we are doing here. So index signature. So basically this is an index signature, right? Key colon t colon d. So the signature, this is called as index signature. This is my what I mean. Yeah, this is called as index signature. Now the way of writing this is you have a key, and then you have the way we read it is for this object all keys of type t must, so this is all keys of type t must have value of type c. So index signature let's safely add, so we can, yeah, this is doing that safe addition of further types. For example, we don't know, later on we might have, for example, we can add so if we can, yeah, optional isn't the only modifier that we can use when declaring objects. You can also mark fields as read only, that is declare the field that can be modified, so we make it on read only. Okay, so instead of options you can do it read only. That's one more type. The object literal notation is one more special case, empty objects. Every object except null and undefined is assigned to an empty object, making it tricky to use, right? As a final note, objects will mean that one last way of typing something as an object is pretty much using the same and is best avoided. To summarize, so I have object notations is called a shape. This is when you know empty. So yeah, try to avoid empty. Object type is when you just want an object and you don't care about the field it has. Object type again. Type aliases unit and intersection. You are quickly becoming grizzled TypeScript programmer. We have seen several times and how they work. Yeah, if you have a type, you can perform some operations of it too, right? I'm going to introduce a few operations here. Type aliases. Age is but a number. Okay, so so you can do this something like, yeah, make little bit sensical. So you can define it somewhere outside. Say this is number, and then when you have the object here, so here we can say so instead of using, yeah, let's only have, so here we can say age is age. So this is an alias, right? So yeah, I've used this thing here, basically like an aliasing. Okay, where was your type alias? You can substitute in the type aliases, changing the meaning of your program. So again, you can, instead of manually doing, we are using multiple, you can do that. And the TypeScript is a special type of operator to describe unions and intersection. This, I guess, is more sort of. Also, we have cat or dog or both, so you can do cat or dog direct union. So if I have a type cat, say that is. Uh, Also, you can okay, do some operations with this aliasing thing. Okay, either you can say it should have one, or you can say I guess what he's trying to do is, So it has to be cat or dog, right? Either cat or either dog. So type can be anything, right? We can create our own types as well. So when you see this, when we see something like, say this cat is type this, right? This is the type. So if I say type, this is type. So this means type of type age is called a cat, where the object has one property age. The age is not a number, but exactly the number. But this will okay. So if it's if I have any object that is confining to this, it should have that age specified with the oh. So okay, this is a type like it's alias by cat. This is called as a literal object type. So you can have literal object types as well. When I did study little bit, there is something with index signatures. But the problem with that is that age also has to be the same thing, right? So an object type defines the structure, keys, and values that the object is going to take. Uh, Again, so a type can be anything. Like so, remember this is doing aliasing, right? And we can have any type. For example, you can say it is a type of class object because JS is that heavily object OOP feature comes into existence, right? So everything is. Oh, I guess that is why it's able to do that. Basically, you can have any type. Like so, it's not mandatory to only have the default. You can have anything. No, no, what I'm we can have anything as a type. You can have anything as a type. So it can be string. You can do anything. So so there are something called as primitives. There is something called oh let's Wait. Some more detailed version is types can be classified into, so you can have three types, like there are three major things. First is the primitives one. This will be a string, number, big int, boolean. These are all primitives. The second thing is something called as, yeah, so we have something called as literal types. So basically this is like, so although this is not a what do you say, valid type, but it can be anything. Then we have something called as object. So for example, you can say a type, but then this has to, whatever is conforming to this is very tight, like tight in thing, because then, yeah, now your yes, give, so yeah, you can have say the key, even the key name, that has to be the same as well if you're saying anything, and you can combine those types using different logical operations. Okay, so now, yeah, you can do union, you can do arrays. Now now let's come to some important part, right? This is something that is going to be, now like in JavaScript, TypeScript, there is a special kinds of objects that support things like concatenation, pushing, searching, slicing, because it's top on JavaScript, right? Now TypeScript supports two syntaxes for arrays. Oh, now, yeah, again, here is again that typing thing that is going to come now. Now, t oh, so now whenever you are mentioning an array, right? Again, the type has to be mentioned, right? So there are two ways of doing that. So one is you kind of do array and say which thing is here, like which array. For example, oh, this is just, yeah, this is like indication and array. Now this is going to be which array, is it number, string, or what? The other way he's saying is you can do it by using the generic way, right? Array. So both are valid, perfectly valid. As you read through this, I can notice that everything is implicitly. So if it's not mentioned, then it's going to be implicit. The general tone of thumb is to kept now. You also notice that a TypeScript has rules about what you can, can't, and can, what you can put in the array and what you can't. General rule of thumb is to keep array homogeneous, that is, to not mix apples and oranges and numbers in a single array. Try to design your own program so that every element. Also, is so our goal is to have an homogeneous array, not a homo is same, right? To see easier things, homogeneous makes it easier, right? On the other hand, when I initialize it, I read a number string. So TypeScript for that it must be an array of type string, number or string, because oh, now what if, yeah, so this is something we need to understand. Okay, now what if when we have a heterogeneous, this is homogeneous. Now what if I have, this is an implicit, right? So the way it would be inferred is this is an array. Now either it can be a string or it can be a number. Oh, this is something cool. So you have to query, because it can be an array or a, this is something cool. Not tuples. Tuples are subtypes of arrays. These are special way to type arrays that have fixed lengths with the value. We won't be working with this that much, but it's okay. Now tuples support optional elements too, just like an object type. I don't need to tuple. So why? I mean, so the whole point is why did they even introduce tuples here? Because JS does not have tuple, right? Or JS has tuples, I guess. Do we have? Yeah, there is no built-in type tuple, but we can simulate tuple using arrays. So then this function, it is just this in TypeScript. The tuples are added because JavaScript often uses array. JavaScript does not learn. So there is three issues with JavaScript arrays, right? First is obviously type. First is type. Second is there is no rule to enforce the length, right? It can be anything. Third is like position specific, right? There is nothing like position specific. You can do anything with JS arrays. So that is why you have something called as tuple. It's like making more rigid though. Okay, so now what we want to do is what we want to have is a you can have a list and list. Okay. Now JavaScript has two values to represent an absence of some null and undefined. Now TypeScript supports both of these values and it has also types for them. Any cases what they are called, yeah, it is called as null and undefined. Now both are special types because in TypeScript the only thing of type undefined is the value undefined and the only thing is null is null. JavaScript programmers can use we generally use it interchangeably, right? Now if there is in the absence of a value then we say it's a null. Undefined is when you haven't declared the variable and you're trying to use it. So that is when you will logically it should be undefined there, right? Again, now strict null checking. Now in older version of TypeScript, strict null checks uh, nulls behave a little differently. It is a subtype for all types except never. So we are talking about the hierarchy, right? So we said that the any is the godfather, right? We never want to go to the godfather. Enums. Now again, this is something cool. Okay, this is not present in default by. So we have something called as enums. This comes in TSC, right? In this TS TypeScript thing. Enums are a way to enumerate the possible for a type. Enumerate basically means all possible values. For example, if you have say tell me uh, all possible languages. So then I can say English, Spanish, Korean, Thai, so many, right? Then you have Russian, you have French. Again, you have regional languages. So many. So basically, this is when we use indicating all possible conditions or all possible enumerate. Now you can split our enums across. So this is again a feature that has been added by TS. Oh, sorry, by TypeScript, right? Inherently, they are not present in. So this is a little bit advantageous at times. A constant enum does not lead to. So there is little bit additional feature that is going to add, right? It is going to add enum. Say yeah, again, const is not going to add, right? If it's a const enum, then no, we cannot do. Now in summary, TypeScript comes with a bunch of inbuilt types. So summarizing this, we can say TypeScript has some inbuilt types. So inbuilt is like boolean, string, then you have symbols, you have numbers. Okay, then you can do something for objects. You can use object literals. You have subtypes. Then you have enum, again constant enum. What will the type? So yeah, you can even match and mix around with types. Remember, any is the godfather of all types. Okay, so yeah, I guess that is all for this session. I hope you guys liked it. I'll see you guys in the next one. Till that time, take care.